glad you're here. I want to talk to you about engineering, but first, I want to tell you a story. Imagine that you're walking through the forest and you hear somebody calling. You hear a woman's voice calling, "Hello, hello!" As you come toward the sound, you enter a clearing and you see a tower. And the tower is really tall, really smooth, with the sides polished like glass. You don't see any door and just one small window. As you approach the tower, a woman calls down to you, "I'm so glad you're here. I need your help. A witch has trapped me in this tower, and every night she climbs up here using just my incredibly long hair. I want to escape, but I need your help. Can you think of a way to help me get down? We have to be fast before the witch comes back." What would you do? We're going to think like engineers, and we're going to design a way to help Rapunzel escape from her tower. And the way that we're going to start out is we're going to just use some materials that you might have lying around your house. So what I have to start out with is I have some tape, I have a couple of soda pop twist-off bottles, a couple of rubber bands, a hole punch, some scissors, an empty soda pop bottle, little toy, we'll call this Rapunzelsaurus, and got some paper clips and some string. So the first thing we're going to do is, as we're thinking like an engineer, we got our materials, we know what our project is, we have to save Rapunzel, we want to get our zipline to carry her as fast as we can from our starting point to our ending point. And the next thing we're going to do is we're going to think and plan how we're going to make our zip line. So if you've ever seen a zip line, usually there's a little basket. And the first thing we're going to do is make our basket. So I decided to make my basket out of a plastic bottle. And what I'm going to do is just cut my bottle down a little smaller. You could also use a plastic cup or a paper cup or a paper towel holder, cardboard tube. If you don't have a plastic bottle, you can think like an engineer and just think about what you have around the house that would work. So I'm going to just kind of lay my scissors across my top of my bottle, and this is where I'm going to cut my holes. So I just kind of use the scissors as a straight edge. And then I'm going to come down just about 1/8 of an inch. And I'm going to cut 2 holes in my bottle. So got 2 holes. And the way I think that this is going to work best is I'm going to take a rubber band and I'm going to kind of fold it up, stick it through the hole, and I'm just kind of tie a knot in it. And this is going to be what's going to let my zipline basket attach to the hook that's going to make it go down the line. So I'm just going to tie a little knot in my rubber band. Then I'm going to take another rubber band and I'm just going to kind of loop it like that. So I thought first I could take a regular paper clip and I could unbend it so it makes kind of a hook. So this is my prototype zipline basket. We're going to put Rapunzelsaurus into the basket, and next we're going to have to string our zipline, and then we can test it and we'll see if this is the best idea we can come up with or if there's a way we can go farther and faster. So let's go test our zipline. Alright, here we are out in the museum at ScienceWorks, and I am some momentum on them. I just used a couple of binder clips to attach my Zipline. You can use tape, that might work for you. And we are going to just go get our gondola or basket and send it down the line. So we've got our S-shaped hook, and we are going to, remember, we're going to loop our rubber band, attach it onto the hook, and I'm going to get out my stopwatch. If you don't have a timer, you can use the stopwatch function on a cell phone. So I've got my stopwatch function up, and if you have a partner or friend, sometimes this is a little easier with two people, but you can do it yourself. You just want to make sure you put your hook up at the highest point you can reach on your line, and then you're going to count down from 3, 2, 1, start! It took 2 seconds, 2.68 seconds, to get Rapunzelsaurus from the launch point to the bottom of the zipline. Not bad, but I think we can do better. So I'm going to reset my stopwatch, and this time we'll try with the So what are some reasons you think it might not have worked quite as well with our curved hook? If you notice, that curved hook was really kind of touching the, kind of rubbing against the string a lot, so we're getting some friction. And so that was slowing down our descent. With the pulley, we shouldn't have that friction, so we should be able to see that we can go a little bit faster. So we're going to pull up our loop again. And before we go any farther, I'm going to stop. We're going to say that we went 6 feet in 2.68 seconds. Now, when you do this with your designs, you're going to do 3 trials with each design. So you see I have that it took 2.68 seconds to go 6 feet on the string. I know how long the string is because we pre-measured our string. So what you would do is you would try with the hook 2 more times, and you would record that data before you move on to using your pulley. But we're going to skip ahead to our pulley. All right, so when we tried the S-shaped hook, we could move a little bit down the string and it could go at a speed, but I think we can do better. So I'm thinking like an engineer, and I want to improve my design. So what I thought I might do to improve it, I thought I might make a pulley. So what I want to do is I've just got 2 soda pop bottle lids, and I'm going to just use some hot glue, and I'm just going to hot glue them together. So whenever you're using hot glue, I want to remind you guys that we need to be really careful because it is super hot and it really hurts if it gets on your skin. So there's a little smoke coming off of here, and basically I'm putting red hot liquid plastic on top of the lid. So we don't want to get that on our skin. If you do not have any hot glue, one thing you can do is you could just use really, really, really strong tape. But if you do have glue, I think that's a really good thing to try to use because it's just gonna stick your materials together a lot faster and a lot tighter. So I just made a little pulley, and our pulley is gonna run down our zipline string like a wheel. Maybe you've been to ScienceWorks before and you've tried the pulley chairs, so you know that we can move things very smoothly and quickly. What I want to do next is I have to attach my pulley to my basket. So I'm going to take my S-shaped hook and I'm just going to bend it into a different shape. And I'm going to kind of bend it into a U, like that. And then I'm going to bend the tops of my U like that. So that we can attach our rubber band to our pulley. So I'm going to pull up the rubber band, put the pulley through it, and then we'll just clip each end like that. And stick Rapunzelsaurus back in the basket, and we're ready to go test out our improved design, and we'll see if we can go any faster than design number 1. So let's go try it.
All right, so we had really good results with our hook. I would like to experiment with some pulleys. We started out taking a couple of red bottle caps, and there was one step that I didn't tell you about. So after you glue your bottle caps together, you're going to want to make a hole in your bottle caps, because you're going to need to be able to put your metal pieces that attach to the gondola basket into your pulley, or else it will just slide and fall off the string and it won't turn. So I made another homemade pulley example, and this is just 2 other bottle caps. I drilled a hole in the middle. If you're not able to use a drill, or you don't have an adult who can help you with the drill, you could nail a hole in the middle of your bottle caps. And then I stuck a little piece of a very skinny straw through my hole, so that when I put my metal pieces onto it and attach it to the basket, my pulley can turn. So it wants to turn like a wheel. So if you make your own pulley, part of the fun of playing around with pulleys is you're going to be really thinking like an engineer, trying it, seeing how well it pulls on the string, and changing it again. I've already made a lot of changes to this pulley, and I'm going to need to make some more before it really works the way I want to. So far, my pulley has got about 2 inches. So I'm going to have to make some more, but what we're going to try now, we're going to use this pulley that's already made. If you want to try something that's already made and you don't have a pulley at home, one thing that works really well is Lego tires. If you take the rubber part off the Lego tire, it works super well for this project. So that's another thing you can try. I'm going to really encourage you engineers to really think and iterate. Think like an engineer and make changes on your pulley designs. First, let's see if we can get what kind of speed we get, what kind of distance we get with this pulley. Just like we did with the hook, I'm going to slip it here and we're going to put the pulley in place. We need to make sure our metal arms of the paper clip are threaded in, but we also want our pulley to be able to turn, so that is something you're going to have to play around with. Now we're going to put our pulley up at the highest point of our launching area. I'm going to grab my stopwatch. We're going to balance the pulley on the string. And we're going to see if we can save Rapunzelsaurus faster with the pulley than we did with the hook. So 3, 2, 1, go. 1.71 seconds. So a lot faster than even our fastest time for the first trial. We're going to go through 3 tests again. So We went 1.71 seconds, 10 feet, and we'll try that 2 more times and see what our average is. And then I'll finish up with you guys and tell you what your final challenge is. So for our pulley test, our fastest time was way faster than our fastest time with the hook. It was 1.71 seconds and it went 10 feet. Our slowest time was where it kind of got caught, it fell off the string, and it only went 3.5 feet before it stopped. I didn't count that extra part where it slid down. That was our slowest time of all, which was 5.31 seconds. And then our last test went about 9 feet in 1.91 seconds. So we'll go and I'll give you the rest of your challenge.
Okay, so the basket moved different with the pulley. Now we're gonna try something different. You guys are gonna make your own design and then you're gonna test it. So I want you to think about what we did for our first 2 iterations of the design. And I want you to think about what you have at home that you could use. And you can either change your basket, you can change the way that your basket moves on the string, or you can change some other variable. What would happen if you had something that weighed more in your basket? So I want you to draw your changes on your data sheet, and then I want you to test it. You'll do like we did when we tested our first 2 designs. You'll record how fast your design went. And then there's a little engineering report that I want you to fill out to be ready for when you meet up with your other engineers to discuss your different designs, any problems you had, and ways you figured out how to solve those challenges. So good luck, engineers. Have fun, and I'll see you later. Stay curious.